Welcome to our channel. In this lesson, I want us to discuss chemistry practical. And the concept that we are going to discuss here is in organic analysis. This one, we usually call it a test for cations and anions. Remember, chemistry practical carries 40%, which means each mark is 1%. So that gives you now 40%, meaning you need to put more weight or more emphasis on the practical. Now, test for cations and anions, it usually forms question 2, and this one carries about 12 marks. I usually call it 12 free marks. The students will have the concept involving in their fingertips. Now, inorganic analysis involves test for cations and anions. Now, for the student to obtain good results, they must be able to, number one, accurately identify the various test reagents that are used. Now, when you're given the paper and you have known that that question is testing for cations and anions, you must be able to understand which reagents are used for which test. Like now, some of the reagents that you usually use for testing cations and anions is sodium hydroxide, aqueous ammonia, lead nitrate, barium nitrate, and so on. So you must be able to identify the various test reagent. Number two, you must be able to identify what these reagents test. That is sodium hydroxide, what does it test? Aqueous ammonia, what does it test? Lead nitrate, what does it test? Barium nitrate, what does it test? You must be able to understand that. And then after doing so, you must be able to predict the expected observation. Once you use sodium hydroxide to test a certain sample, then you must be able to understand, or you must be able to predict the expected observation. Will you get a white precipitate soluble in excess, or will you get no white precipitate, or will you get white precipitate insoluble in excess, such thing. Now, usually the basic test for gases include smell of the gas. There are those gases that have a pungent choking smell. You must be able to identify the color of the gas. There are those gases that are colorless. Others have green, yellow, like chlorine gas. Another one, brown, like nitrogen dioxide. And then effect on moist litmus paper. The word here is moist, meaning it should have moisture, right? So there are those gases that turn a moist blue litmus paper to red. So meaning those gases are acidic. There are those that turn a moist red litmus paper to blue, meaning those gases are basic. So the other basic tests include action on lime water. Like you know, carbon dioxide is tested by passing it through lime water, that's calcium hydroxide, for a short while, and therefore it forms a white precipitate. From there, you need to know preliminary tests, which usually include number one, flame test, number two, heating of solid in a test tube or a boiling tube, and that is thermal decomposition or thermal dissociation. And then the third one is solubility of the solid in water. Preliminary test means you cannot identify or you cannot confirm the presence of a certain cation or anion in a sample by using this preliminary test. This one just gives you a basic foundation of the test that you are going to carry out. Now, to start with the flame test, this one is usually used to identify the presence of a cation. Cation means a positively charged particle in a solid or a solution sample. A flame test is usually done by using a spatula, or you can use a nichrome wire. The procedure is you heat a half spatula full of solid K, just an example, using a non-luminous flame. So you take the solid, you scoop it using a spatula, and then you heat it using non-luminous flame. So the observation that you make, that is now the flame test. The flame test now that you make here depends on the cation present in that sample. So expected observation here can be solid burns with a yellow flame. So the inference conclusion becomes sodium ion present. Why? Because sodium salts burn with a yellow flame. Now, or it can be solid burns with a lilac, that is purple flame. The cation present here is potassium ion. Or solid burns with a red flame. The cation present here is calcium ion. or solid burns with an apple green flame. The cation present here is barium ion. Solid burns with a blue-green flame. The cation present here is a copper 2 ion. Or solid burns with scarlet flame. Scarlet means dark red flame. So the cation present here is a lithium ion. Next is heating of a solid in a test tube or a boiling tube. The salt which is heated here in the boiling tube or the test tube may either be heated gently, that is thermal dissociation, or strongly, that is thermal decomposition. Heating of the solid gently, it involves a removal of water of crystallization from a salt. Now, sample procedure, you place a spatula of solid K, just an example, in a test tube or a boiling tube, and then you heat it gently. So we said when you are heating a solid gently, what you are trying to remove is what? Is you are removing water of crystallization. Now, what is the expected observation? The expected observation will be a colorless liquid is formed on the cooler part of the test tube or the boiling tube. The inference conclusion becomes hydrated salt present. Usually, we reject when the candidate or when the student writes a colorless liquid condenses. Remember, a liquid does not condense. So the correct observation here is should be colorless liquid forms on the cooler part of the test tube. Now, we have heating of a solid strongly. When we are heating strongly, then it is important to observe changes in the color of the solid being heated, effect of litmus papers, effect on burning or a glowing splint, color of gases produced. So here we have a sample procedure. Take a spatula full of solid K, an example, in a boiling tube, heat it strongly, and test the gases produced using a moist litmus papers, that is both blue and red. So before you dip that litmus paper into the mouth of that boiling tube or the test tube, you have to moisten it. So expected observation, if you get a white solid changing to orange when hot and yellow on cooling, then you need to know the conclusion or the inference for that is lead ions present. Or when you get a white solid changing to yellow when hot and white on cooling, then the cation present here is zinc ions. You get blue solid changes to black, the inference is copper 2 ions present. You observe brown gas produced, then the inference is nitrate ion present. If you observe a wet blue litmus paper changing to red, it means acidic gas produced. When you observe wet red litmus paper changing to blue, then it means ammonium ions present, or here you can say a basic gas produced. Now that preliminary test is dissolution or dissolving of a salt in a water. This one is usually done to identify the presence or absence of colored ions, the presence of a soluble salt and insoluble salts. You have here sample procedure. 1. Take spatula full of solid B, an example, in a boiling tube and add about 10 milliliter distilled water and you shake well. Now expected observation, remember you are taking a solid, you are putting in a boiling tube and you are adding 10 ml of distilled water, you shake the mixture. The observation that you can get is this solid may dissolve in that distilled water to form a colorless solution, or this solid may partially dissolve in that water to form two layers, that is maybe a colorless filtrate and a white residue. So what is the expected observation here? If you get solid dissolves to form a colorless solution, then it means the inference that you are supposed to write here is colored ions absent. Why do you say absent? Because here we get colorless solution. And the colored ions which are absent here usually are copper 2 ions, iron 2 ions, iron 3 ions. But if you are unable to write this formula, don't commit yourself. Just write colored ions absent, full stop. Now, if you get solid dissolves to form a blue solution, then it means now copper 2 ions present. Now, what if the solid dissolves in distilled water and it forms a green solution? Now, you need to know that it is copper 2 ion or iron 2 ions present. You see, there are some copper 2 salts which are green in color. So here you have to also mention it. Now, sample procedure 2, you take a spatula full of solid C in a boiling tube and you add about 10 ml distilled water and you shake well and you filter it. Now, once you are told filter, it means now that salt is made up of two salts. One is soluble and the other one is insoluble. So meaning the insoluble is going to form a residue while the soluble is going to form a filtrate. Now the expected observation here is it says solid partially dissolves in distilled water to form a white residue. That's if you see a white residue. You may see a black residue. So you write what you see there. And a colorless filtrate. But if the filtrate is blue, you will say a blue filtrate, a green filtrate, and so on. So the inference here is you say probably soluble and insoluble salt present. Now that brings us to the end of our lesson. For more videos, subscribe to our channel. Thank you for watching.